Chapter 6 Review. Problem 1. We want to convert from degrees to radians. We multiply by pi over 180. Notice that the degrees cancel and we're left with radians. Simplify, you get pi over 3 radians. Each time we're converting from degrees to radians, we multiply by pi over 180. Problem 3. We want to convert from radians to degrees. We want the radians to cancel, so we put them in the denominator. We multiply by 180 over pi. The pi's cancel. 5 halves times 180 is 450 degrees. So each time we're converting from radians to degrees, we multiply by 180 over pi. Problem 7, we're given that the arc length is 100 feet. The central angle is 70 degrees. We want to find the radius. Our equation is that the arc length S is the radius times theta. Theta must be in radians. When we put theta of 70 degrees into this, we have to convert it to radians, so we multiply by pi over 180. That gives us 1.22 radians. We divide both sides by 1.22 and we get 81.85 feet for the radians, or for the radius. Problem 9. We're given that the distance between the two cities, which is on the curved surface of the Earth, that's the arc length, is 2,450. It tells us that the radius of the Earth is approximately 3,960. So put that into our equation. We will solve for theta. We'll get 0.6186869. Notice that's in radians. If we want to convert it to degrees, we have to multiply by 180 over pi. Problem 17. I wrote this wrong. So if we want the sine of 40 degrees, it's not x over 5. It should be y over 5. So the sine of 40 degrees is y divided by 5. 5 sine 40 equals y. So y is 3.21. This is wrong too. Should be 5 squared equals 3.21 squared plus x squared. And if you solve for x, you would get x is 3.83. Next page, problem 21. We have right triangle trigonometry. We want to solve for a and b. The sine of 20 is b, opposite, over hypotenuse 3. b is 1.03. We can use the Pythagorean theorem to solve for a. Problem 29 is interesting. Notice that we have the distance from the Earth to the surface of the moon, which would be this point right here, is 236,900 miles. The radius of the moon plus that distance represents the hypotenuse of our right triangle. That top right triangle we'll be using. We have to divide our angle measure in half if we're only using one of these right triangles. So that gives us 0.259 degrees. The hypotenuse then will be 236,900 plus the radius. So the sine of 0.259, our angle, is the opposite r over the hypotenuse, 236,900 plus r. We multiply both sides by 236,900 plus r. Use the distributive property. We get 236,900 sine 0.259 plus r sine 0.259. That equals the radius. We're solving for r, so we need to subtract r sine of 0.259 from both sides. Factor out the r. Divide both sides by 1 minus sine of 0.259. On the left-hand side here, make sure that you put the denominator in parentheses as you feed it into your calculator so that you will have the subtraction happening before you do the division. That should give you that the radius is 1,075.74. Problem 33, you want to find the tangent of negative 135. Just locate that on your unit circle. You should be over here at negative, or the angle here will be pi over 4 or 45 degrees. So you're at the point negative square root of 2, negative square root of 2, and so the tangent is positive 1 there. Cosine of 585. Once again, find it in the unit circle. That's the same thing as 225 degrees, or 5 pi over 4. So negative square root of 2, negative square root of 2. So the cosine is negative square root of 2. 390, negative 390 degrees. You go clockwise, you go 360, then you go 30 degrees more. That puts you here at square root of 3 over 2, negative 1/2. Know your unit circle. We're asked to rewrite tangent squared in terms of sine squared. Tangent is sine over cosine, so it's sine squared over cosine squared. Cosine squared plus sine squared equals 1, so the cosine squared is 1 minus the sine squared. Sine of theta is 3/5. In problem number 53, we are also told that the cosine is less than 0. The cosine is negative in the second and the third quadrant. The sine is positive, so that means we must be in the second quadrant. We draw our triangle. The sine is the opposite, 3, over the hypotenuse, 5. We solve for the remaining side. We get negative 4. That means that the cosine of theta is negative 4/5, and we use our opposite, adjacent, hypotenuse, and our reciprocal relationships to solve for the remaining values. 57, it asks you to find sine squared plus cosine squared. That's always 1. Doesn't matter where you are. Problem 69. We're given two sides in the included angle. We have to use the law of cosines. Plug those values in, take the square root. You should get 148.07. Make sure your calculator is in degrees. Problem 73. Notice this is side-side angle. When it's side-side angle, there are ambiguous cases. It could be there is no solution if the sign is negative or greater than 1. It could be there's only one solution. And it could be that there are two solutions. We solve for theta. Theta here is 54.1. There's another value of theta, 180 degrees minus 54.1. You must subtract 54.1 from 180 degrees to get the second value here. Problem 79, it's two sides in the included angle. We have to use law of cosines again. And we get 3.87 miles. Problem 81, we're asked to find the area. We're given two sides in the included angle. We know that the area of a triangle can be found by multiplying 1/2 times the product of two sides and the sine of their included angle. So that gives us 32.12. Problem 82, we know three sides, so we have to use Heron's formula. The semi-perimeter is S. It's 1/2 times the sum of the three sides. That gives us 9.5. And then we multiplied the square root of 9.5 times 9.5 minus each individual side. That gives us 14.98. Going back to problem number 78. We're trying to calculate the height of the building. We have two triangles here. The triangle on the left, which I've outlined in red, it's an obtuse triangle, and then the triangle on the right, which I've outlined in green, which is a right triangle. We need to know the height of the building, which is a part of the right triangle. In order to calculate that, we need to know one of the sides of this right triangle. A is a side that the two triangles share, so that's the one we're going to calculate. We need to calculate side A in the red triangle. We have 24.1 degrees as the angle of elevation at point A. We can calculate angle B here. We know that this angle ABC, and our angle of elevation, 30.2, have to add up to 180 degrees. So 180 minus 30.2 is 149.8. That's this angle right here, this obtuse angle. We can add this angle and subtract from 180 to get the third remaining angle in this triangle. That will give us 6.1 degrees. We can use the law of sines for our red triangle. We have A over sine of 24.1 equals 600 feet over sine of 6.1. Solve for A, and you should get 2,305.56 feet. Notice we don't really care what that distance is. We just need it. We need more information in this green right triangle so that we can solve for the height. This is not the only way to work this problem, but it just seemed like the best way to me at the time. So now we're working in the right triangle, the green triangle. We know this is 30.2 degrees. We know this side. We want to know the height. So we have opposite and hypotenuse. That's sine. Sine of 30.2 degrees is h over 2,305.56. Multiply both sides by 2,305.56, and you should get a height of 1,159.74.